Surface mining of materials like coal and other resources require a synergy between a multitude of mobile and stationary equipment. From removing overburden with drag lines, loading haul trucks with shovels, and all the processing, sorting, and conveyance equipment involved, surface mining companies require the right piece of equipment to be functional when they need it to meet production demands. Safety is priority number one in the mining industry. The sheer size and close work proximities of all this equipment make this mandatory. All equipment must be closely monitored for safe operations. Not having cracked or otherwise compromised equipment parts is a crucial part of a safe operation. The falling of a boom from a large drag line can cost millions of dollars, even without human injury. These costs can be incurred from repair, replacement, investigation, downtime, and lost production. The loss of a single haul truck can slow production rates significantly, since they carry from 40 to 100 tons of product per load. Repair services and parts for such massive vehicles is costly and time-consuming, so early detection and monitoring of potential problems in all equipment is crucial. Mining companies worldwide, like most industries, utilize non-destructive testing techniques and instruments to ensure safe and reliable operation of their equipment. Many hire outside testing services, but many perform the inspections with their own personnel. Stringent NDT testing on mobile equipment is essential, as these vehicles are usually very large, under massive stresses, and interact around other mobile equipment operators and support personnel. Advancement in the core NDT technology of industrial ultrasound have led to improved inspections and therefore increased productivity and safety in surface mine operations. The improved ease of use, reduced cost, and increased industry-wide acceptance of phased array ultrasound have allowed increased access to mining operations to improve their NDT programs with this exciting technology.
Yeah, phased array has been great for us because we're able to get into a lot more areas than we were able to before. With conventional UT, you're pretty limited on your access, and you have to have such a greater sound path. So with phased array, we get all those other angles in a shorter span. We do a lot of work to AWSD 1.1 and table 6.2 and 6.3, and those require us to use 45, 60, and 70, depending on the thickness of the part, so we can get that all in one shot. So it really saves the time it takes us to UT a weld.
Phased array offers wider coverage, better POD, recordable results, and increased ability to monitor defects for growth while retaining portability for difficult access areas. Because of the flexibility of phased array, a single probe can be applied to many different inspection scenarios and applications without changing equipment. Mining equipment ultrasound applications can be difficult. Large and long parts, complex geometries, reduced access without complete disassembly are only a few of the inherent difficulties faced by NDT inspectors in the mining industry. Many tests are designed as a best fit, or require multiple wedge changes or special transducers to be designed to accommodate the test.
We do have some parts that we had to draw out in a CAD model and figure out which angle's the best. And one part, for example, we found out that a 55-degree angle was the right angle you need for that part to find that crack. And with phased array, we can pretty much eliminate buying that 55-degree wedge and just use our regular transducer and wedge on that.
Conventional ultrasonics can only be applied at one angle at a time, limiting the coverage and detection capability, especially when the components are in place in the equipment. If a crack is found, typically only the inspector's measurement or a report is saved. Swing shafts are a critical component in drag lines. As it is preferable not to shut down the drag line, manual ultrasonic inspections are usually done in place. Identification of a crack is left to the operator's ability to identify the defect in the A-scan display while moving the probe. With the shaft in place, the ultrasonic inspection is limited. Phased array offers a sweep of beams allowing more coverage of the shaft from the accessible area. Imaging makes the inspection more reliable, especially on shafts with known cracks that are being monitored. Adding a scanner or encoder to the inspection makes these inspections more reliable by being able to inspect from the same exact position each time. Drag lines and shovels contain many bores or lugs connecting components together with pins and shafts. These are high-stress areas that tend to crack on the inner diameter. They can be difficult to inspect when in place due to probe access restrictions from other components and reflections from geometry of the part or other parts. Phased array allows more inspectable area from the accessible area, and the imaging helps the inspector understand the geometry signals more clearly. Many other components can also be inspected. Almost all mining equipment has many sizes of gears. Gear tooth integrity is crucial to continued operation. Knowing the extent of cracking and if a gear tooth will break off is critical. The inherent benefits of phased array, proven by 20+ years of use in other industries, are a big advantage for typical mining industry applications. The use of multiple angles and imaging increases coverage, reduces scanning times, and provides better detection and characterization capabilities, especially in crack growth monitoring situations. Phased array can reinforce and enhance mine predictive maintenance programs and in turn increase profitability. Current trends for lower cost and easier to operate units make these instruments more accessible to mine NDT personnel, enabling the conversion of conventional ultrasonic tests to phased array ultrasonic tests. For more information on Olympus Mining Solutions, contact your local representative or visit us online at www.olympus-ims.com.